Good morning, you guys. For section 2.5 for pre-calc, the information that's on this front page here, I'll let you guys read it. It's not something that I necessarily need to go over. It's the procedures that I'm going to be following on the next couple pages. It's there as notes. It's a step-by-step instruction on what you need to follow through. So I don't think there's any reason I need to read it. To solve for all zeros, so again, all the zeros you have would be rational, something that you can write as a fraction, whether it's that or like that. Something that's irrational, whether it's like this, or 7 minus the square root of 3, or something that involves an imaginary number. So I, or 2 plus 3i, or 2 plus I square roots of 3. It's all zeros, any number you can think of. So the first place you start is finding the possible zeros. All the factors is 16. There goes my 4s again, all over, plus and minus 1 and 3. Then you graph it to look at the graph and see which ones of these could possibly work. Well, I need something near -3. And looking through here, there's no way I'm going to get a -3. It's not possible. This is the list of rational zeros, so zeros that can be written like this. It's not going to find irrationals or imaginaries. Now looking at the graph, it's degree 3, and you see 3 x-intercepts. So that means that there are 3 real zeros, so there are no imaginaries. There can't be. There's going to be 3 real zeros. Since I'm already looking at this and going, there's no way I got a -3, there's no way that I get a +3, that I'm sure, I'm convinced that those two, this one and this one, are going to be irrational. They're going to involve a square root. This one here, let me get rid of the stuff around it so I can see it a little better. I'm looking at, is that 3/5? Is it around 3/5? Is it around 2/3? Is it around 3/4? Somewhere in there, something near that. And the only thing from the list that's near that is 2/3. That's why you build this list, so you have some place to guess. So 2/3 looks like my only guess. You take it, first you type the equation in so you can see the graph. Then you take it, that your guess, and you check it. Is it actually a 0? And it is. So you take the 2/3 and you divide it out to expose what's left. So 3, -2, -24, 16. To drop the 3, that gives you 2, 0. 0 times that is 0, -24. 2/3 of -24 is -16, so 0. And that's what you should get when you go ahead and find a 0. Otherwise, it's not a 0. It's not a factor. Now, when you have a denominator that's other than 1, you have to divide everything but the remainder by that. Now, in this case, it doesn't matter whether you divided the remainder or not, because it's still going to be 0. But just letting you know, you divide everything but the remainder. So your actual answer is 1, 0, -8. So you've got remainder, number, x squared. So your answer so far then is going to be x squared minus 8. And to find the remaining zeros, set it equal to 0, add the 8, take the square root of both sides. So x is equal to plus or minus square root of 8, which is 2 square roots of 2. Then as a final check, you go and you take and fill those numbers in. And those are the two numbers, negative square root of 2 and positive square root of 2. And they do come up zeros. So you verified that those things are zeros. So you found all the zeros for this equation. To make a list of them, how about that? And what was it, 2/3? So this would be a list of all the zeros. This one, it's degree 3. Type the thing in your calculator. You're looking for 3 zeros, whether they're rational, irrational, or imaginary. Again, you're looking for all zeros. And looking at the graph, there's only one zero. Real zero, I should put out. One real zero. So right away, you know if there's one real zero, there has to be two imaginary zeros. Two answers that involve I. Right? So verify that's 2. Well, I mean, you can make your list, plus or minus 1, plus or minus 2, plus or minus 11, plus or minus 22. 2 is on the list. Take 2 and put it in your calculator. It does indeed give you 0. So take the 2 and divide it out. 2, 1, negative 8, 23, negative 22. Drop the 1, 2, negative 6, negative 12. So that'd be positive 11. 22, 0. So your answer, remainder, number, x squared. So you've got x squared minus 6x plus 11. You have to do the quadratic formula on that. There's no way it's going to factor. There's no way. Otherwise, they would be showing up as real zeros. So x is equal to the opposite of v, plus or minus the square root of negative 6 squared minus 4 times 1 times 11, all over 2. X is equal to 6 plus or minus 36 minus 44. 36 minus 44. So it looks like negative 8, whoops, is inside the square root. And let's see, I got negative 12 when I did it before. I guess I can't count. 36 minus 44. Should be negative 8, right? Yep. Yep. Okay. So then that becomes 6 plus or minus 2i square roots of 2 over 2. And the 2 is going to reduce in both of these. So your answer is 3 plus or minus I square roots of 2. Now, it says, and write the polynomial as a product of linear factors. Well, that's 2 zeros, and your other 0 was 2. So the first part, that's pretty straightforward. X minus 2. There's one factor. Then I have x minus, and I'm going to write it with parentheses, 3 plus I square roots of 2. And x minus 3 minus I square roots of 2. So then your final answer then is x minus 2, x minus 3 minus I square roots of 2, and x minus 3 plus I square roots of 2. Okay, that would be your final answer. Is there another one? Find all the zeros. Well, when they give it to you factored, it's pretty straightforward. You're really just doing the zero product property. X is equal to 0. X minus 3, technically squared, is equal to 0. I'll talk about that in a second. And x plus 5 is equal to 0. So x is 0. Square root both sides. You really are just left with x minus 3 is equal to 0. So 0, 3, negative 5. Now, technically, if I was being super duper picky, I would have to write 3 twice. But I wanted to show you on a graph. This is called a double zero. And all double zeros look like this. See how these just cross the thing? If I were to zoom out, you'd see this graph doing this. Okay? That's what it would look like. And this is right here. When the graph just touches at an x-intercept, that's called a double zero. This is what it looks like. It's going to come and hit the x-axis right like that. It literally means that that 0 appears twice. Do you need to list it twice? I don't think so. But I just need your vocabulary to be there that whenever you have something like this, it would be called a double zero. And the graph is going to hit just like that. There's nothing that says it has to hit it from above. It could come and hit it from below. That's not a problem. Yep, you can just touch it just like this one did, but doing it from below rather than doing it from above, that's totally okay. So this one, setting them equal to 0, x cubed is equal to 0, so x is equal to 0. So then x minus 3i is equal to 0, so then you get 3i. X plus 3i is equal to 0, so then you get minus 3i. If you want, you can write it x is equal to 0 plus or minus 3i. That's totally okay too. I really don't think you guys are going to have a whole lot of problems in doing this. X plus 3 minus the square root of 2 is equal to 0. Add the 2, subtract the square root of 3, so minus 3 plus the square root of 2. X plus 3 plus the square root of 2 is equal to 0. Subtract the square root of 2, subtract the 3, so x is equal to minus 3 minus the square root of 2. So if you want, you could write x is equal to minus 3, and the plus and the minus goes on the square root of 2. Whoops, why did I write a 3 there? I have no idea. Sorry about that. 2. That's a minus 2 and that one's a plus 2, but the 3 is subtracted in both of them. So there you go. You can write them separate or you can write them together. I don't have a preference.